Okay, so we're going to continue with chapter 9. Today we're going to learn how to first find the determinant and then how to use the determinant that we find to solve a system of a linear system. So far we learned how to solve it algebraically, and then we also used the Gauss-Jordan method of matrices to solve. So now we're going to solve by finding the determinant, and then we're going to learn a technique called Cramer's rule. So the first thing we need to do is identify or define what a determinant is. So every matrix could be written as a determinant. Notice when it's written as a matrix, it's got brackets around the numbers. And then when it's written as a determinant, it looks like absolute value bars, 2 bars straight going down. Now, these little numbers that are at the bottom of these letter A's are just telling you the position of the number. So, for example, this A11, this is telling you that this A is in column 1, row 1. This A21 is telling you that it's in row 2 and then column 1. So it's telling you where it's located in either your matrix or your determinant. Then 2, would be row 2, column 2. A12 would be row 1, column 2. So it's telling you where it's located. So the way that we're going to find the determinant of a 2 by 2 matrix, we're going to do cross products here. So we're going to multiply the first position, so row 1, column 1, times row 2, column 2, and get that product. Then we're going to multiply up this way and do row 2, column 1, times row 1, column 2, and that would be that product. We're going to get those two products and subtract them, and that will give us the value of the determinant of matrix A here. So let's try it with some actual numbers. So again, I'm going to be multiplying, and I've got a little typo here. In my matrix here, this label here where it says 23, there should be a 22, because this is row 2, column 2. So that should be a 2 here. So I'm going to find the value of matrix A, I am going to multiply down this diagonal, and that'll give me this product, and then up this way, and it'll give me this product. Once I get those two products, I will subtract them. So let's go ahead and try it. So I'm going to multiply first the negative 3 times the positive 8. I'm going to subtract 6 times 4. And the value will be negative 24 minus 24, and the value of the determinant is negative 48. Now this is not a solution of the matrix, it's just the value of the determinant. And we're going to be using this value to solve later on in the last couple slides. We're going to just practice finding the determinant first. Let's try another one. Now, you will have to do this by hand, even though you could key this 2 by 2 matrix into your calculator. However, the calculations for 2 by 2 are really simple. So again, I'm going to multiply row 1, column 1 times row 2, column 2, subtract row 2, column 1 times row 1, column 2. So negative 2 times 3, and I end up with negative 9 minus negative 6. Negative 9, keep flip change here, and I get negative 3. Okay, next one. Let's try the next one. Again, we're doing cross products here, going down the diagonals. -9 times 6. We're subtracting the 2 times the 7. And I get -54 minus 14. And my determinant value is -68. So when it's a 2 by 2, it's nice and basic, nice and simple. Now we're going to try a 3 by 3. Now you will have to demonstrate how to find the determinant value of a 3 by 3, and you'll also have to be able to key this into your calculator. I'm going to first show you how to do this by hand, and then we'll go ahead and do it in our calculator. Now, notice they've taken matrix A and they've turned it into determinant A by adding in those bars around it. Again, the labels on this 1, 1, these are staying the same. Now, again, we're still doing multiplying down the diagonals. However, notice this would give me this product, but then for my next product, it's telling me that it should be the A12 times the A23, and then also times the A31. The easiest way to do this is I'm going to go ahead and rewrite my determinant. So let me go ahead and rewrite the original. So I'm going to write A11, A12, A13. I'm rewriting everything here and show you the easiest way to create the diagonals that we need to get our products. Let me go ahead and fill all of this in. I'm going to add my bars here. And now, in order so I can get 3 diagonals across to get these 3 products, I'm going to rewrite columns 1 and 2. So I'm going to rewrite column 1, which is the A11, the A21, A31. And then I'm going to also rewrite column 2, A12, A22, A32. Now, to get my products that I need, again, I'm going to number these. So the first product, which is this one, I'm going to go straight down here. And notice that these are the same numbers in this first product that I've highlighted here. Then the second one, and I'll call this 2, is now going to be this diagonal that I just made by rewriting columns 1 and 2. Then my third product, which is this one over here, call this 3, is going to be down this diagonal. And now to get what you're subtracting, I go from bottom to the top. So this one I'll call 4. And I would go from bottom to the top. And then to get the middle one here, call this 5. And that'll go diagonally up this way. And then the last one, I'll go ahead and do this one in blue again. And I go up this way. So now it makes finding the products when you're having to do this by hand a little bit simpler. So now let's go ahead and try this with some actual numbers. Everybody good? Anybody still need this? All right, I'll wait for a second. Okay, so again, I am going to rewrite columns 1 and 2 outside here. So 6, 8 and 1, 2, 9 and 2. It makes it a lot easier than having to memorize that whole formula. Okay, so now again, I'm going to go down the diagonals. So here is my first diagonal, and I go right through here. So 6 times 9 times 0, and it gives me 0. Then I'm going to go to the next diagonal. 2 times 3 times 1. It's going to give me 2. That's my column 2, so I get plus 6. Then my third column. Go down this diagonal. 4 times 8 times 2, and I get 64. Now I'm going to subtract going up from bottom to top. So I'll go from, call this 4, and again 1 times 9 times 4, and that gives me 36. And then the next, call that 5, 2 times 3 times 6 gives me another 36. And then lastly, 0 times 8 times 2. Anything times 0 is 0. So I'll put plus 0. Going to add each of the brackets or the parentheses. So I get 70 for this one and 72 for this one. I subtract them and I get -2. Good? Let's try number 5, and then I'm going to teach you how to do it in your calculator. So now that we've got these values, when we go back and I teach you how to do it in your calculator, we're going to double check that we get the same answer when we use our calculator. Everybody good on number 4? Let's try number 4. Exact same matrices into your calculator. Okay, so to key, I'm going to do number 4. So the way that we're going to key a matrix into our calculator, we're going to first turn on our calculator, and then
We need to be in degrees or radians?
in radians. I go ahead and we're going to turn our calculator on. Then you're going to hit the second key. So it's either your blue button or your yellow button. And then you're going to come down 4 keys to the X to the -1. If you notice the word above that key, it says matrix. So you're going to touch that button. And then it's going to open up. It's going to say names, math, edit up at the top. And then it's going to have the letters in ABC order. We're going to go ahead and move our cursor across so we highlight the word edit. So move the cursor across until you get edit, and then you're going to hit enter. It's going to give you the option to put in the dimensions of your matrix. So this one that we're doing on number 4 is a 3 by 3. So I'm going to go ahead and change the 1 to a 3. And then move it over. Change this 1 to a 3. And then I hit enter. Notice I now have a 3 by 3 matrix. And now I can enter each one of the elements in the matrix. After you hit each number, you need to hit enter after each one. So now, after each entry, so now what you're going to do is your cursor should be highlighting this very first 0. So you're going to hit 6, enter. Then hit 2, enter. And enter in each one of the numbers in number 4's matrix. Okay, then I'm going to hit 4, enter. 8, enter. 9, enter. 3, enter. 1, enter. 2, enter. 0, enter. Okay, you should have entered 9 numbers. Now that you've entered the 9 numbers, now we're going to get out of this. So whenever you want to quit out of anything, you hit the second key and then you hit the quit or the mode. So I'm going to get out of this. And now I want to go back. So now I'm going to hit second and matrix again. So second and then the matrix button. This time, instead of highlighting enter or edit, I'm going to move the cursor over so it's highlighting the word math. So move it over 1. Notice option 1, DET, that stands for determinant. So we're going to either select 1 or if it's already highlighting 1, hit enter. On your screen, it should say DET within open parentheses. we now need to put the letter of the matrix that we entered. And the way that we're going to get that letter, again, we're going to hit second in matrix again. Second matrix. Select where you entered your matrix, whatever letter it is. So it's already highlighting number 1 for me. So I just have to hit enter. And then you can close the parentheses and then hit enter. -2. The same answer we got when we did it by hand. The whole purpose, 5. Again, rewrite columns 1 and 2. So 2, -1, -1. -3, -4, and 0. Again, go down the diagonals. 2 times -4 times 2 gives me -16. Then the next one, -3 times -3 times -1 gives me -9. Then I'll go down the next diagonal. -2 times -1 times 0 gives me 0. I'm going to subtract now, going from bottom to top. -1 times -4 times -2 gives me -8. Then the next diagonal. As soon as I see I'm multiplying by a 0, I don't even have to think about what the next numbers are. It's just my product is 0. Then the next diagonal. 2 times -1 times -3 gives me +6. I'm going to add my terms in the first bracket. I get -25 minus -8 plus 0 plus 6 is -2. Keep flip change. So -25 plus 2 is -23. Now I'm going to walk you through the steps of keying this into your calculator. So let's see. And the of finding the determinant is to help us. I'm going to solve system of equations, and we're going to be using the determinant when we apply Kramer's rule. So I'm now going to demonstrate how to solve a 2x2 using Kramer's rule. So it's going to have multiple steps, so make sure you're paying attention on how we have to set up each one of these determinants. So the first one that I'm going to set up, I am going to call this letter D. And in my determinant, I'm only going to use the coefficients. So the coefficients of the variables. So the numbers I'm going to put in for D is going to be 5 and 7, 6 and 8. So these are the X's, these are the Y's. Okay, I'm going to multiply 5 times 8 minus 6 times 7. And I'm going to get 40 minus 42 equals -2. I now need to set up another determinant, and I'm going to call this one dx. In my dx determinant, I am now going to replace this x column with the solution column. And in your original equation, these are the solutions down here. So instead of putting 5 and 6 in my column, I'm going to put the solutions, which is -1, +1. I'm putting back the y column. And now I have to solve this determinant or find this determinant. Again, multiplying the products diagonally, Negative 1 times 8 minus 1 times 7. Negative 8 minus 7, and I get negative 15. I now need to do the same thing for the other variable that I have in my system, which is going to be y. So dy, again, I'm replacing the y column this time with the solutions. I'm putting back my original x's, and now I will solve this one. So 5 times 1 minus 6 times negative 1. 5 plus 6, because minus minus, gives me 11. I am now going to take these three determinant values and use them to find the values of x and y, or the order pair where my two equations cross. And the way that I do that, to find x, I take the value of dx, divide it by the value of d. My dx was negative 15, and my d is negative 2. So the value of x in my system for that order pair is 15 over 2. To find y, I'm going to take dy and divide it by d. dy was 11, and again my d was negative 2. So the y of my order pair is 11 over negative 2. So the answer to this system is going to be the order pair 15 over 2 and negative 11 over 2. Again, remember the solution to a system of equations are the points where the two equations cross. So this is the order pair where these two equations cross. We're now going to do a 3 by 3. We are going to get the determinant values from our calculator. However, we need to write down each one of the determinants that we're going to enter, or each one of the matrices. Let's get them all written down, and then we're going to key them into our calculator, and then we'll divide to get our triple. So again, our original D is just the coefficients of the variables. So we're going to put in a 1, and a negative 1, and then 2, negative 1, positive 1, 1, negative 2, positive 3. So go ahead and key that in your calculator, and let's see what everybody gets. You should be getting negative 3 for your first determinant value. Now we're going to repeat the process and find a dx. So for dx, remember the x column gets replaced with the solutions. So I'm going to put negative 2, negative 5, positive 4. My x and y columns, my y and my z columns stay the same. 1, negative 2, negative 1, positive 1, and 3. Again, I'm going to key this in my calculator and get the determinant value for dx. Once you key this in your calculator, you should get 7. I need to also find my dy. I'm rewriting the x column. This time the y column changes to the solutions. The z column stays the same. I'll key it in my calculator, and I find out that dy equals negative 22. I now have to repeat it and now do dz because I have 3 unknowns in this problem. The other one was only 2. This time the z column gets the solutions. So the -2, the -5, and the 4. I'm going to write down column, the x column is the same. The y column is the same. Key it in your calculator, and dz should equal -21. Once you get these values, now we're going to divide them, each one, by the original d. So again, to get x, I could do it next to it. So x is going to be dx divided by d, which gives me 7 divided by -3, which is just -7/3. Then y, -22 over d, which is -3. Negative and a negative, I'm going to simplify and make it positive, 22/3. And lastly, for my z value, -21 over -3, which gives me +7. So my ordered triple here is -7/3, (22/3), and +7. And that's your ordered triple. So we've already learned how to solve 3 by 3s using the algebra, substitution and elimination. We've learned how to solve them using the Gauss-Jordan method. And now we've learned how to solve the system using Kramer's rule. So we've learned another technique for finding the values of x, y, and z. So practice with your calculator. You do have homework. This homework is not due until Wednesday because I will not see you tomorrow due to the ACT and the Aspire testing. So this will be due on Wednesday. I'm now going to show you another way to solve it using your calculator. This app button is only on the newer calculators. So if you have one of the newer TI-84 pluses or TI-84, you can do this. And it's really cool. So when you're taking the SAT or the Aspire or the ACT tomorrow, you can use this if they ask you to solve a system of equations. It's really easy to use. I'm going to show you a short video because my calculator on the board does not have this app function. So instead I have a video I'm going to show you instead of me holding my iPad camera on top of my calculator. So I'm going to show you a video. Watch it. You can probably use this tomorrow or when you take the SAT or whatever you're going to be taking, any standardized test.